on the back page of 3.7. We've mostly completed that top row. And remember, we had just looked at, okay, remember a number add or subtracted at the end is up or down direction of the sign. A number add or subtracted in the parentheses is left or right opposite the sign. And then the ones we ended up with, numbers multiplied at the front, if they're bigger than 1, they're vertical stretches. If they'd been a number between 0 and 1, that would have been a vertical compression or shrink, whichever word we want to use there. Okay, and all these particular ones were based on the parent function. Note these shapes because we're going to need these down in the bottom section here. The cubic function, y equals x cubed, so this is what your graph of the cubic function looks like. And the quartic function, y equals x to the 4th, it kind of looks like a parabola, but it's flattened out on the bottom more. Okay, and so that ends up making it a version of the quartic function. Okay, now, as we talk about this real quick, some key things I want to point out. As you look at the cubic function, because as we look down below, we're going to have to be able to decide what these graphs do. Realize the cubic function, it goes through the point 0, 0. It goes through the point 1, 1. And it goes through the point -1, -1. Okay, so those are some key points to notice in the cubic function. Okay, and that's your basic, no movements, no stretches, nothing. The quartic function, you'll notice it goes through 0, 0 as well. It also goes through 1, 1, and it goes through -1, 1. So again, those are some key points to kind of notice. This is your basic shape without any stretches, without any compressions. And that'll be helpful to know. Okay? Okay, let's look at the bottom half of the notes here. In this scenario, they're giving us graphs. Okay, they're giving us graphs, and they want us to write the equation. So the directions ask us to determine the equation of each graph as it relates to its parent, and notice it says cubic function or quartic function. So they're telling you right now it's a cubic or a quartic. So it's an x to the 3rd, or it's an x to the 4th. So just to straighten out that these parabola-looking things you see, they aren't x squared. We're going to use x to the 4th. Okay? Now, so as you look at A, what I would suggest you do, kind of go through and identify what graph is this? How is it moved? How is the shape different? What transformations are you seeing here? Thoughts?
Cubic.
Okay, can we agree it looks like a cubic? If you look up right up in the section right above, it looks like it is an x to the 3rd graph, right? So I know I'm going to use x to the 3rd when I write my equation. What else?
Negative.
What do you mean negative?
It's going down. So going down to right.
Okay. So you're noticing that our cubic on the other page goes, is this what you're talking about? It goes like that?
Yeah.
And this cubic is going like that, right? Okay. So it's the difference in the shape. What causes that? What causes it to change that? And think in terms of transformations of it.
Like a negative x to the 3rd.
Okay, a negative because it's a what? What's a negative? What's the word I'm looking for? What type of transformation?
A reflection.
A reflection. Okay, so what this graph has done is it's a reflection. And it really could be across either axis, depending on the scenario. But it is going to be a reflect. And how are we going to use a reflect or do a reflect? We're going to use a negative. Okay? So I agree, there's going to be a negative involved. What else do you notice about this graph?
3 points.
Okay, there's just 3 points. Are those 3 points similar to what we had as the 3 other points? In other words, if you go back here and look,
Yeah.
does it have the same shape where you have your center point, where over and up, over and down type thing? It is. They're going opposite ways, but that's because of the reflection, yes? So my point there is there's no stretch or compression because it has the same relationship to that centering point. But what do you notice about that center point? Is it at 0, 0?
No.
No. Where did it move?
2, 4.
Okay, so it moved
Right.
right 2 and up 4, yes? Or as you guys said, I agree, 2, 4. I'm just trying to gather all my details. Okay. So we know it's a cubic, it's reflected, it moves right 2, up 4. We have all of our information. Our job is to write the equation. Okay. On these, you could either start y equals, or what I have written in my notes is f of x equals. I'm kind of thinking the homework's going to start with f of x. Thoughts of how to write this?
Would it be f of x equals negative x cubed, in parentheses, like x minus 2, and then out of the parentheses plus 4? Or something like that?
Something like that, yeah. So, what did you say there has to be? It's a reflection, so there's a negative. Okay? Now, I'm going to put that negative out front. But, what else is being done to x? Because there's that negative out front, but then to go right 2. How do we show right 2? In your parentheses, you put what? X minus 2. Up 4 is plus 4. Now, one major detail that we're missing. What type of equation was this? It was a cubic. Where do I put that power of 3? Okay. This is where it has to go outside the parentheses. If you put it on the x, that minus 2 isn't meaning right 2. That minus 2 would mean down 2. So it has to go outside the parentheses, so that minus 2 means right 2. And that's what we're looking at, guys. F of x equals negative of x minus 2, quantity cubed, plus 4. Okay? Did you kind of see how that goes together? Next one. Okay, on B. What's the various information you can put together here?
Quartic.
Okay, you guys agree that it's a quartic? It's an x to the fourth. It has that U shape.
It's left 1, down 3.
Okay, to get to this center point is the important point, right? You can't really see that when I'm doing red on red. That's your new centering point that normally would be at 0, 0, yes? So if it normally would be at 0, 0, but it moved, it did go left 1, down 3. Any reflection? No. What about any stretch or compression? Is it normal shape? In other words, right here, to get to that first set of points, do you go over 1, up 1? Over 1, up 1?
Yeah.
You do, don't you? And isn't that the basic shape of the quartic? From the vertex, you go over 1, up 1, right? Okay, so you just have to write an equation for an x to the fourth that goes left 1, down 3. I'll start us off with f of x equals. What do you want to do?
Is it like f of x equals x plus 1 in parentheses with the fourth on it outside the parentheses minus 3?
Yep. Did you guys follow that? That minus 1 or plus 1, that means left 1, goes in the parentheses, right? It's opposite of sign. You've got your transformation list to refer to if you're not remembering what's what. The fourth has to go outside. The -3 indicates the down 3. Okay. Next one.
Vortex.
Yes? The rest of you guys are being quiet. You guys gotta...
I think it's a vertical stretch. Maybe, I think.
Why is there no points?
Okay. Could we put points on?
Yeah.
Where do you see the vertex being?
1.
That point right there? Yes? In other words, I agree, there's no points on, but this is easy enough. We can put points on it. Okay? Like, I think it's fairly obvious. Okay? So,
There's no stretch.
we'll come back and talk about the stretch or no stretch thing here in a moment. Let's get the other piece of information. Okay? Based on where I put this vertex,
Right 1, up,
it goes right 1 according to this, and it goes what?
up 5.
And then that is a 5 there, isn't it? Because along the y-axis, it's counting by ones. Along the x-axis, it's counting by halves.
I just had to trade me.
So can we agree that the graph moved right 1 and up 5? Okay. What else do we need to talk about?
The reflection.
Yeah, it's not a right side up U, it's an upside down U. So that reflect, in order to show reflection, just means we're going to include a negative, yes? Now, this is what Elianzine is back there wrestling with. This is important. You have to decide. Is there not some kind of stretch or compression?
No.
And here's what, Jocelyn's complaint, there's no points. Okay, we're going to put points on it. You saw me put the vertex, right? Where do you see another point? To me, do you guys see these points right here?
Yeah.
Now, it looks like we move over 2 and down 1. However, check the numbering. How far over do we move?
1.
When you move that, that is a distance of 1. How far down do we move? That's also a distance of 1. Is that the normal shape?
Yeah.
Over 1 and then normally up 1, down 1 because it's a reflection. So is there a stretch or compression? There's not. But that's what you check for, and that's how you check it is it the normal over 1, up 1 from the vertex? Make sense? Okay. Well, if there's no stretch or compression, we're ready to write the equation. F of x equals. And are you noticing a theme here, right? They all kind of have the same similar setup, don't they?
Yeah. So I can get a negative, then parentheses, x minus 1, then this would be x to the 4th, plus 5.
Okay. Do you agree with what he told me to write? Does minus 1 tell me right 1 in the parentheses? Does plus 5 tell me up 5 outside the parentheses? X to the 4th, do I have x to the 4th? I do. And do I have my minus for a reflection? I do. Are you catching on how to write these? I know Eliazine is. What about the rest of you? Yes? Maybe? Okay, let's try D. There's no points again, but what am I going to say? Put some points in, yes? Can you see where the center is? Yeah. And then look and figure out where is the next set of points. When you're going over and up and over and down, do you see another set of points that intersect? I do. So without even talking about anything else, is there going to be a stretch or a compression?
No.
No, because from that center point, your points are going over 1 and up and down 1, right? Okay. What piece of information have you guys gathered? What type of graph is this, class?
Cubic.
Then x to the third. How far does it move?
Like
Over
left
3.
3, down 1.
Left 3, down 1. And anything else?
Reflection.
Is it reflection again? Yeah, your normal graph is the increasing one. This is decreasing. So this is a reflection again, which means there's going to be a negative. We already decided no stretch or compression, so we're good to go. Okay, are you writing the equation without me? F of x equals, what goes out front? Negative. Then we're going to have
X. Minus. Oh, plus 1. Oh. Plus 3.
get your left or right first. That's going to go inside the parentheses. So x plus 3 in the parentheses indicates left 3. So the third power. And then down 1 is minus 1. Okay. Last one. What about E? Kind of looks like a parabola to me. But we know it's not a parabola because what did the directions say? These are cubic and quartic. Okay, so we know this is an quartic.
Vertical stretch. Pretty sure. Wait, no, not vertical stretch again. Dang it, dude.
Over to the right 2. Up
7,
6.
6. Is it about 2s? Yeah, it's
Well, here's what I'm going with is they tell me that's 2, 6. So right 2, there's your 2. Up 6, because if you look, this is 2, 4, 6, 8. Any reflection? No, it's a right side up U. So here it brings us back to the same discussion of is there not a vertical stretch?
no.
And here's what I would use, folks. Do you see how they have this labeled 2, 6 and 1, 7? How do you get from 2 to 1? You go over 1. How do you get from 6 to 7? You go up 1. Yes? Okay. And so, you have to notice on the x-axis they count by 1s. On the y-axis they count by 2s. So are they trying to trick you again?
Yeah.
Yes, they are. Just beware. Okay? In homework, you might see some vertical stretches. I don't remember for sure. Okay? But if it's over 1, instead of going up 1 or something, if it goes up 2 or something, or down 3, that's going to be your vertical stretch there. Okay? Okay. F of x equals, what are we writing?
X plus 2 minus 2. Times 2 to the fourth plus 6.
And here's what I always do is at the end I stop and analyze. Does this make sense? Does this tell me what I think it should tell me? Minus 2, does that tell me right 2? Plus 6, does that tell me up 6? Does it say x to the fourth? Okay? You know the pieces here. You can do this, okay? These equations, you have to be careful. Look at the pieces, but this is very doable. Okay, guys, you have lesson 3.7 in Savas. I believe it is quite the opposite of 3.6 is rather time-consuming, but I don't know, maybe I should. If I recall, it seems like 3.7 goes quick. I could be wrong on that. But regardless, you have work time. So if you owe me any math assignments at all, you need to be working on math.
Math.
Okay?
You grid